Welcome to another video, 7.6. Now we're going to look at some of the properties of the equilibrium constant and what we would do to it if we manipulate our chemical reaction. So let's get right into it. So now two of these three things we have already covered. So if we reverse a reaction, we know that the new equilibrium constant is going to be the inverse, or 1 over k, of our original reaction. If we multiply the coefficients of our reaction by anything, right, 1/2, 2, 3, 7, well, our original k value we will take to the power of that factor, and in order to figure out the new equilibrium constant. Okay. And the newest one that we have here is if we have two reactions that we're adding together, the k value of that new reaction is going to be the product of our two k values. Okay. And we'll look at exactly how we get there. We're also going to look at how we get here as well. We have talked about it already, so hopefully this is something that is more of a review for you. All right, so let's say that we reverse the reaction. So our original reaction is AA plus BB yields CC plus DD. So the equilibrium expression is going to be the concentration of C to the power of the coefficient C times D to the power of the coefficient D, and then again on the bottom, A to the power of A, B to the power of B. So we're multiplying them, okay? Products in the numerator, reactants in the denominator. So let's say that we reverse this reaction. So now we have C and D on this side, A and B on the other side. Well, we're going to do the same thing that we did up there. Okay, so A and B are our products now, so they're in the numerator. C and D are reactants now, so they're in the denominator. And this is just this flipped. Okay, so if we flip this, well, we could also just flip the value of k, right? So if we flip this, take the inverse of this, well, the inverse of k is going to be 1 over k. So therefore, our new k, k prime, remember this is just an adjusted k, from whatever our original reaction is. Okay, so k prime is going to be equal to this, just inverted, and therefore it's going to be equal to the original equilibrium constant, also inverted. Okay, so 1 over k. Next, let's say that we take our original reaction, A plus B yields C and D, okay? And now we multiply this whole reaction by 2. So 2AA plus 2BB yields 2CC, sorry about that, plus 2DD. Okay, well, it's going to look like this when we put it into the equilibrium expression. So now everything has been multiplied by 2, therefore the exponent for each of these is going to have 2 in it. So we can factor that all out and take our original equilibrium expression, factoring out the 2, so it's that to the power of 2. Therefore, it would also be equal to k to the power of 2, because this is equal to k. Okay, now for the last one here. Let's say that we have two reactions. A yields C and B yields D. We want to add them together to get this, okay? Well, for this reaction, this small reaction, K1 is equal to C to the power of C over A to the power of A. So product over reactant. And then over here, B yields D. So product over reactant again. So we add them together. This is what we end up with. So remember that the equilibrium expression, products over reactants, okay? But if we were to separate that, we would end up getting C over A and D over B. So it's this times this, because look, we're taking the product of the products and then the product of the reactants down here. Okay, so we just separate that, okay, because this is equivalent to this, right? This is exactly the same as what we have here. But now we've established that this, which is K1, and this, which is K2, if we just multiply K1 and K2 together, well, that's going to give us our updated equilibrium constant for this reaction that we got from adding these two together, okay? So our new equilibrium constant is not going to be the sum of K1 and K2, meaning that we don't add them together. Instead, it's going to be the product of those two. So multiplying K1 times K2 will get us our new updated equilibrium constant. Okay, well that's all for this video. So again, this is hopefully something that you can use for the equilibrium program that you are doing today. Okay, have a nice day.